this. Okay, here's what we're going to talk about today. We're using sigma notation, and there are certain properties of sigma notation that that just happen, and in fact can make your life a little bit easier. And in fact, you have to know them because as much as it's tempting to plug into your calculator, we're very soon going to get to a place where you're going to have to use these. This is kind of a foundation for calculus as well. So here's one thing that you know. One thing you might have found last night is if you have something like this. Sigma, I think the problem I gave you was k went from 1 to 10 of 5. And if, in fact, you were, Jeffrey, going to write that out, it would be kind of tedious to write this out, wouldn't it? Yeah. And notice, there's not a k there at all. There's just a number. So your first output, Tim, is going to be what?
5.
And then your next output?
5.
And then your next output?
5.
Good. In fact, all of them, how many times?
10.
Good. So we have 10 times. Again, there's no k value. So what's the sum, Vivian, of all of those going to be equal to? Exactly. And Anna, is that always going to happen whenever we have a constant? Definitely. So if I gave you something like this, k goes from 1 to 100, and the only thing that I've put in front of that little sigma is a pi. Jake, what's that sum going to be? Pi plus pi plus pi plus.
800. Oh, it's pi. Wait.
It's pi there.
Pi times 1.
Yeah, 100 pi. And here's the one thing that you need to guard against. The one thing you need to guard against is what's a constant going to be. So even if I gave you something like this, k goes from 1 to 100 of q, here's the thing. Because I've defined our variable right down there at the bottom, the only variable we have is k. So that means q isn't doing anything. When k is 1, our output is q. When k is 2, our output is q. When k is 3, our output is q, right? All the way until the very end. So nothing's changing, it's just going to be q. So what will be the sum of this thing? Ellen?
100q.
Yes, just 100q. Okay, and even if you had something like this, k goes from 1 to, let's say, n of p, again, our variable is only k. So what's that going to be equal to, Alana? Yeah, n times p. So whatever we have up here times p. And we could call that should we just call it the constant rule? Whenever you're taking the sum of a constant, it's going to be, the constant rule is, it's going to be the constant times the number on top. So the sum as k goes from 1 to n of some constant, we'll call it c, that's going to be c times n. Okay, good.